Finding out the solutions to equations just like these can be very tricky. So in this video, we'll cover 6 steps that always work to help you find the solutions to questions just like these 3. It's Rami here, let's get into it. Before we start our first question, just be mindful that I made a very similar video to this one, but the angles are in radians instead. The link is in the description below, so be sure to check that one if you're dealing with solving trig equations with radians instead. Let's look at our first question, and we want to find the values of x between the stated bounds. I appreciate that many of you are likely familiar with using cast diagrams or trig graphs in order to find the necessary angles when solving trig equations. Instead, we'll now look at the following 6 steps, and we'll discuss each step in more detail as we go along. Looking at our steps here, the first step states that we want to rearrange the trig equation to make the trigonometric function the subject. However, the fact that the trig function, i.e. sine, is already the subject, we could just skip that first step. For the remaining steps, I'll aim to be as detailed as possible, but in the questions after this one, we'll run through them much quicker. Looking at the second step, it says that we need to convert the bounds to match the angle within the trigonometric function. What this means is that because the angle within the trig function is x plus 30, we need to make the angle within the bounds as x plus 32, not just x. Before changing these bounds, just to give a quick inequalities recap, looking at this inequality on the side, although we know that the statement here is clearly true, if I add 5 to one part of the inequality, we can see that this statement is now false. Therefore, in order to ensure that the statement remains true, whatever you add to one part of the inequality, you must also do to the other part too. So referring back to our question, if we want to add 30 in the middle of the bound, we need to add 30 to all parts of the inequality or bounds. At this stage, I like to set x plus 30 to be equal to a new variable y. So the question just reads sine y equals 1/2, where we have these new set of converted bounds. You don't have to make this substitution, but I like to think that it just makes solving this trig equation a little bit easier in later steps. Looking at the third step, it says we want to find the first angle, alpha, by using inverse trig functions. So in order to find the first angle, which I've labelled with alpha, I'm just going to apply inverse sine to half, which is 30 degrees. Looking at the fourth step, it says that we should follow these set of rules depending on which trig function we're using. Since we're dealing with sine, let's look at where it says 180 minus alpha for sine. All this is saying is that in order to find the second angle, we subtract this angle alpha, i.e. 30, from 180 to get our new angle of 150 degrees. Looking at the fifth step, this is now the tricky bit because we want to work out all the angles. This is where our converted bounds that we worked out previously really become useful. The step says that we need to keep adding or subtracting 360 to each of the angles in the pair to find all the angles within the converted bounds. But why do we do that, and what does this mean? If we think of what the graph of sine looks like for just a moment, we can see that effectively we're trying to find where the graph for sine crosses the line 1/2 on the vertical axis. Notice that because the graph repeats itself every 360, where we see the first solution here of 30, it then gets repeated every 360 degrees after and before that, whereas the second value of 150 degrees also gets repeated every 360 degrees after and before that. So what I like to do here is pair the two values that we just found together. Then for the first value, I'm going to add 360 to get the third value. If this value is in the converted bounds, then I'm just going to add 360 to the second value to get the fourth value. Then I'm just going to add 360 to the third value to get the fifth value. And I'll just keep doing this until the solutions are not inside the converted bounds. We'll now work the other way by subtracting 360 from the second value in our pair to get the one before the first value. Then subtract 360 from the first value in our pair to get the one before that one that we just found. And we'll just keep doing this until the solutions are not inside the converted bounds. I'm now going to cross out any values that are not inside our converted range, as these values are not needed. This now gives us all the solutions within our bounds. However, let's not forget that we're looking for the solutions for x and not for y. So looking at the sixth step, this is pretty straightforward. All we need to do here is just replace y with x plus 30, then subtract 30 from each of the values we just found in order to find the solutions for x. So that gives us a total of 6 solutions. You can easily check whether these solutions work by substituting them into the original equation, but it's not necessary to do this. Those 6 solutions are all the ones that we need. If we refer back to the ones that we crossed out for just a moment, if we subtract 30 from those values, notice that for any values of y that are outside the converted bounds, they will ensure that our values of x are also outside the original bounds. However, for all our values of y that are within the converted bounds, they will ensure that our values of x are in the original bounds. And that's why we crossed out those values for y once we found all the solutions. Now that we've dealt with a case involving the sine trig function, let's try a different case. For this question, we'll just follow the same steps as before, but for your convenience, we'll speed up the process. The first step is that we need to rearrange the trig function, i.e. cos 2x, to ensure that it's the subject. So all we need to do here is just divide by 4, so we just get left with cos 2x equals 2 root 3 over 4, which is the same as saying root 3 over 2. Looking at the second step, it says that we need to convert the bounds, like last time. So we'll now multiply all the values in the bounds by 2 to ensure that the new bounds are the following. And like last time, I'm going to replace the 2x with y for the trig function and bounds. Looking at the third step, I'm just going to apply inverse cos to root 3 over 2 in order to find the first angle, which is 30 degrees. Looking at the fourth step, we follow these set of rules depending on which trig function we're using. Let's look at the one for cos. All this is saying is that in order to find the second angle, we subtract the value we just found from 360. And this leaves us with 330 degrees. Looking at the fifth step, I'm going to just keep adding multiples of 360 to each of the values in our pair over and again until we find a value outside our converted bounds. Likewise, I'm going to just keep subtracting multiples of 360 to each value in the pair over and again until we find a value outside the converted bounds. I'm now going to cross out any values that are not inside our converted bounds. Those solutions are all the ones that we need. So looking at the sixth step, we need to replace y back with 2x, then divide by 2 from each of the values we just found in order to find the solutions for x. So that gives us a total of 4 solutions. Let's move on to one final question, which this time involves the tan trig function. For this question, we'll just follow the same steps as before. We can ignore the first step since tan is already the subject. So looking at the second step, it says we need to convert the bounds like last time. This time there's 2 operations to go from x to half x plus 60. So if we think about things in terms of a number machine, we need to multiply the x by half first to get a half x. This leaves us with these new bounds. Then we'll add 60 to get half x plus 60 degrees. So this leaves us with our final converted bounds. Like the previous questions, I'm going to replace the half x plus 60 with y for the trig function and bounds. Looking at the third step, in order to find the first angle, I'm just going to apply inverse tan to 1, which is 45 degrees. Looking at the fourth step, we follow these set of rules depending on which trig function we're using. Let's look at where it says 180 plus alpha for tan. So in order to find the second angle, we just add 180 to the value we just found. And this leaves us with 225 degrees. Looking at the fifth step, I'm going to just keep adding multiples of 360 to each value in the pair over and again until we find a value outside our converted bounds. And it should be clear that we don't need to subtract 360 from each value in the pair, bearing in mind that they're already outside the bounds. Although both values of 45 and 225 degrees from our original pair were outside of our converted bounds, we still needed them to get the other values that were in the bounds. This is why we didn't cross those values off until we found all the required values in the converted bounds. I'm now going to cross out any values that are not in the converted range. So looking at the sixth step, all we need to do here is just replace y with a half x plus 60. Now we'll just subtract 60 from those values, followed by multiplying all of them by 2 in order to find the solutions for x. So that gives us a total of 3 solutions. Now that we've covered solving some really tricky trigonometric equations with some really awkward bounds, you've now got the skills to tackle some similar questions to the ones that we covered in this video. So that's going to do it. I hope you managed to get something out of today's video. Don't forget to subscribe for more free content just like this, and turn on all notifications so you don't miss any uploads from this channel. If you have any questions, just pop them in the comment section below. Thanks for watching, and I'll catch you in the next video.